Okay, so as I said before, you are going to read this chapter 6, where you will get instruction about executing the experiments listed in the lab syllabus. Okay, so the first experiment is to visualize the single and multi-band image. Okay, so before starting the execution, first you need to understand what do we mean by remotely sensed data. Okay, so as I discussed in the theory class, in the remotely sensed data, specifically if I talk about images, so in the images, the digital numbers are stored at the different location of pixels on the ground. Okay, so an image consists of an array of pixels. We call them elements, are grid cells. Okay, and they are ordered in rows and columns. So elements, so it's a center point is designated in terms of row and column. That gives you the idea about its location in the image. Okay, so in two-dimensional Euclidean space, the pixels digital numbers are represented, and each pixel has a digital number, and that represents the intensity of received signal reflected or emitted by a given area of Earth surface. Okay, I hope my screen, shared screen, you can see at your end. Hello?
Yes, sir.
Yes, sir, it is visible.
Fine. Okay, good. So there are certain terminology that you need to understand before starting the experiments. And though we have been already discussing about those terminology, like what do you mean by picture element, what do you mean by grid cells, what do you mean by fine. So if I consider specifically the definition of digital number, so a digital number is a particular number. It is in a decimal format, decimal number system format. Okay, and it represents the amount of energy that is reflected or emitted from a smallest area element that is uniquely defined in grid cells. Okay, so whatever the amount of energy, total amount of energy that is coming from that area element, okay, that is assessed by the sensor, and a particular digital number is assigned. Okay, here we represent digital number in the computer system store digital number in sequence of binary numbers. Okay, when we talk sequence of binary numbers, and it in terms of number of bits we are using to represent the different numbers. Okay, like whether it is a 2-bit, 4-bit, 8. Okay, so if we fix the number of bit, it means we have a range of digital numbers which are available to assign the values to the return intensity from the area element, ground element. Okay, so let's say if we consider 8-bit image, though in this experiment you are going to use the 8-bit images. So we have a range of digital number from 0 to 255. What does this mean? It means let's say if we consider large area. Okay, so what that sensor does first, our entire area into grids. Okay, and each grid has a square size. It is square shape. Okay, and similarly these grids are connected together. Each grid is, the energy coming from each grid is sensed by the sensor, and a particular energy signal strength is recorded. So similarly, from the entire area, you have a large number of energy signals, okay, which are recorded over there. Further, what we do on the basis of number we are using to represent these energy signals into the equal segment. Let's say if we have a 8-bit image, sensor has capability to store the information in 8-bit image. Okay, then the entire energy signal strength that is coming from the grid cells, okay, they are equally divided into 255 segment. It's a 256 segments. Okay, and further, if let's say 0 to 1, 1 to 2, and similarly like that. So there is a mapping from energy signal strength to the decimal number we are using. Okay. So then corresponding digital numbers will be generated for the energy signal strength, which is sensed by the sensor. Fine. And if you consider the size of area belonging to a pixel is called spatial resolution. We'll discuss about it. Like when I take this grid size, shape and size of the grid. Okay. So shape of the grid is square and size of the grid, that is one side of the square grid, is called as spatial resolution of the image. Okay. So the digital number that is produced in a sensor system dependent on the range geometric values. It means what is the range of ground area element to the sensor and what is the reflected energy that is coming out from that area element. So DN number depends on these parameters. Okay. Similarly, one important aspect over here is if you sense the image in a different band, okay, so reflected energy from the given area is different if you change the wavelength. Okay. So with respect to the wave band which are used for sensing the area element, okay, the energy received is different. This is the reason why we do the imaging in a different spectral bands. Okay, so of the object which is there, that object reflectance is different in a if you consider two separate wavelengths, so the reflectance will be different. So that is a unique property of object, how that object reflect the energy in a different band. Okay, so that will be sensed in the form of images, and it will further help you to classify the object. So this is the reason why in this laboratory you are going to use the multispectral imaging system data. Okay. It's not a single band. You are going to use the multi-band images, and each band data is given. So visualization step will be discussed by the Mukesh, how you can open the image, okay, and after the visualization, what kind of information you could able to get from the image. Let me first discuss about the image characteristic in terms of how many bands are there. Please wait for 1 to 2 minutes. Just I'm again sharing my screen.
मुकेश वर्मा ये कनेक्टेड नहीं करा।
कनेक्ट करना है।
वही पढ़ा रहे थे अभी तक रिमोट सेंसिंग।
Okay, so you are going to use the data set where many single band images are given, okay, and they are 8-bit image. So the area from where this data is acquired, it is in Bolivia, okay, and there are Landsat thematic mappers, satellite imaging sensors are there. So if we consider this TM thematic mapper band 1, okay, so the characteristic of this band we define in terms of this what is the bandwidth. So the given bandwidth is 0.45 to 0.52 micrometer, fine. And the second band is it's TMB3, then TMB4. So this TMB3 is 0.63 to 0.69, and TMB4 is 0.76 to 0.9. So this TMB4 band is in infrared band, okay, and the band first and third, they are in visible spectrum. And I already discussed why we go for the multi-band images. The reason is that when energy falls on any object, that object reflects the energy, but that reflected energy magnitude varies with respect to wavelength. Okay, let's say if we consider the same ground area element, okay, and if you see if you sense the energy in TMB1, okay, So that amount of energy that reaches to the sensor, that magnitude differs with respect to the energy that is sensed in TMB4. Why it is so? Because in different spectral band, the response of material or response of object is different in terms of reflectance. Okay, so uniquely that object is recognized, and that object is represented in a different bands. Okay, and that unique representation in different band will be finally helpful for identification of object as well as classification. Fine. So these are some basic fundamentals which will be required for starting this experiment, and the remaining theory part I have been already discussing in this PRS course. So what we have discussed till now related to this experiment, the definition of certain terminology which will be frequently used in this laboratory course, as well as how we define digital number, what do we mean by pixels, okay, and what do we mean by number of bits which we use to represent digital numbers, okay, and further what is the significance of using multi-bands to acquire the information from the given area. Okay, now as I said before, the objective behind the multiple experiments which we are going to conduct in this course is to improve the visual quality of image, okay, and to identify interpretation, as well as to apply certain operators to get some information, like to identify the object or to classify the objects which are there in the area. Okay, so the algorithm behind that and the set of instructions, mathematical steps will be discussed, and the implementation of those steps have been already done in this software, that is ELVIS software, as discussed by the Mukesh. Okay, so you will have a kind of experience like how by clicking the certain buttons over there in the software, how you can generate the result. Okay, but main goal should be to understand, if you click a particular button, then what kind of algorithm is running behind that. Okay, so simultaneously you also need to understand like if you select a particular option, if you click it, so inside the software, what are the set of instructions through which that data process and you get the result. If you understand that part, then you can able to write your own script the way the software is written in this this ELVIS software, a set of instructions which are written in this software. Okay, so your goal should be to understand the set of instructions and related mathematical aspects, and for executing the objective of the experiments. Fine. So now I again ask Mukesh to kindly proceed.
Okay, thank you, sir. I hope I am visible to the other side. To install the software, you need to go through the ELVIS academic software provided in the meeting chat. So continue it and you can install the software. After the installation, you need to activate the software. To activate the software, you need to use the patch. Patch will ask for one file that is available in the your installation folder of Ilvis Academic. Go through the Ilvis 3.3 academic folder. In that folder, you will get the file named Ilvis 30, and you need to select this file in the patch. After that, follow the given steps and the software will be activated. Those who have already installed the software in their PC, they can follow the steps given in the chapter 6 for the experiment 1. And now I am showing you the list of the experiments that will be performed in this laboratory. There will be 4 experiments. The first experiment in this laboratory is the visualization and image statistics of single band and multi-band images. As you cannot perform these experiments in your mobile phone, so you can use your PC to perform the experiment simultaneously. So it will be better to use your PC. This is the interface of the Ilvis software. In this, you have operation list, operation tree, and the navigator. And in the operation list, you have the many number of operations. And before conducting the first experiment, you need to place the data in a certain folder. I will use the UG data 06. So I am copying this data and placing it in a folder. Make one folder and name it as Ilvis Experiment 1. Paste the data in that folder. Now through the Ilvis software, you can navigate to that folder. My folder is at desktop. So in the desktop, the folder name in which the data is placed is UG data 06. So we can open that folder. Mr. Praveen, you can close your camera and also the mic. So for the image visualization of the TEM bands, so after clicking the TEM bands, we are getting here the 7 band of images. So by double clicking on the image, we will get this window. In this window, we can see the minimum value of DN is 25 and maximum DN value is 162. Click OK and this image will be visualized. In this manner, we can open the multiple images together to compare the changes in the images. So we can also open the TM band 3. And in this way, the multiple windows can be opened together to compare the changes in the images. So this is the visualization of images. After that, we'll try to explore the statistics of the images. For that purpose, we can go to the operation tree. In the operation tree, we have the statistics. In the statistics, we have the histogram. And from the histogram, we can select the TM bands. Suppose we want to see the histogram of TMB1, then we can select the TMB1 and we can open it. After that, this histogram will be represented. From the histogram, we can analyze many things from this histogram, that the pixel values are ranging from 25 to 100 approximately, and we can see the minimum value of the pixels in the histogram and the maximum value of pixel and total number of the pixels, mean and median of the pixels. In this way, we can note the many things from this histogram, like what are the total number of pixels in the image, what is the minimum value of the pixels, maximum value of the pixels. And suppose we want to see the histogram of TMB2, then we can click on histogram and select the TMB2. In this way, the histogram of the TMB2 will be represented, and we can see the mean of the pixels is different from the TMB1. If we want to visualize the multi-band images, we can make the color composite here. In the red band, we can select the TMB1. Green band, we can select the TMB2. And then blue band, we can select the TMB3. And we can click OK. So now this image has been opened as the color composite. And we can visualize the image up to the pixel level we want. If we will zoom the image, it will open as the pixels, and we can see the color at each pixel is different. Each pixel is having a definite DN value and the corresponding color. We can minimize the images also by using the minimize button. And we can also see the statistics of these images. From the options, we can go to the show histogram, and this histogram will be presented. So now we are able to see the histogram of individual images and note down certain things, such as what is the minimum value of the pixels, maximum value of the pixels, and standard deviation of the pixels, median of the pixels, and the area covered by these pixels. And after making the color composite, we can also see the histogram of that color composite image, and we can also see the properties of the histogram. So students can also perform this experiment at their end. If they are facing any issue, they can ask me. If there is installation issue, they can also ask.
सर ये कलर वाला फिर से बता दीजिए.
Okay.
Sir.
हाँ जी.
Sir, what is actually histogram and how it is representing the image correctly?
As it has histogram has been already discussed in the theory class, but histogram is the representation of the DN values, the number of points in a certain. I think there is some disturbance.
Yes, sir, a lot.
हेलो सर.
Yes.
सर ये जो हिस्टोग्राम है जिसमें वाई एक्सिस है ये नंबर ऑफ पिक्सेल्स को रिप्रेजेंट कर रहा है, और जो सर एक्स एक्सिस है वो सर उस पे तो कुछ लिखा नहीं है, तो क्या होगा सर?
X axis, suppose we have a number, we have a very small image, suppose 3x3 image, okay, and it is having DN value as 11 at the two places and DN value as 50 as at three places. So the frequency of the pixels will be represented in the histogram. Okay.
सॉरी सर, आप स्क्रीन शेयर करिए सर, दिख नहीं रहा है.
Let me further explain. See, the histogram of an image describes the statistical properties of the image. Okay, like as I discussed before, image is represented by digital numbers. Okay, and they are discrete numbers lying between 0 to 255 if we consider 8-bit image. Okay, so if we have a very large area and grid cells are there, and each grid means I'm talking about ground area element, the smallest ground area element that is assigned a unique digital number. Okay, so there are large number of cells from the ground. Okay, and the energy which is coming out from each cells, that energy is sensed by the sensor, and further a signal strength or intensity is generated. So the intensities which are generated corresponding to each grid cells, okay, that intensities range between minimum and maximum value, and they are the analog signals. Okay, so let's say if we have a image size in terms of number of pixels which we have in the image, let's say they are 2000. Okay, so 2000 pixels for if image size is 2000 pixels, it means there are 2000 cells from the ground. Okay, so corresponding to each we have a intensity value. Okay, so we have a there is a possibility we can have a 2000 distinct intensity values. Okay, now these 2000 distinct intensity values are assigned digital numbers. Okay, but we have only certain unique digital numbers. If it is 8-bit image, then we have only value 0 to 255. So 2000 distinct intensity values are further mapped in 0 to 255 scale. So there is a possibility a few of them falls in the same bracket and they are assigned the same digital number. Okay, so when we plot the histogram to statistically analyze the image, then on the independent axis, that is x-axis, we have a digital number. The range of a digital number, it is, if in case of 8-bit image, it is 0 to 255. Okay, So we have a discrete, it's 0 to 255 levels on the independent axis, that is x-axis, and on the y-axis correspondingly we assign the value to the digital number, how many times they occur in the image. So that is a frequency of occurrence of the same digital number in the image. That will be recorded on y-axis, and we call them the frequency. Fine. Just see that if Mukesh, could you plot that histogram corresponding to one image like this TMB one? If you analyze the histogram of an image, it will tell you somewhat idea about what kind of features are there in the image. Okay, just see this histogram. The range, that the domain, that is the value of digital number on x-axis, it is 0 to 255. But most of the pixels, they are concentrated within the certain range. And you can see in the statistic, the minimum is this given in the statistic? This minimum, just click over here. Okay, so just see that from where that histogram start, that point represent the minimum digital number, and where it ends, that will be the maximum digital number. Certain point, we call it unimodal distribution. Okay, unimodal means at one particular pixel value, we are getting the peak. Plot it again. Okay. So you know that in the image, we have a array of digital numbers. So in the image product, there are only array of digital numbers. Nothing other information is available. Okay. And by analyzing those numbers only, you need to interpret the image, and you need to identify the objects. We need to classify the object once you are going to write your own algo. So this is the reason why statistically you need to analyze these array. Okay. So the given pixels array, you need to analyze it. And there are certain parameters which are used for statistical analysis, like what is the minimum value of digital number, what is the maximum value of digital number. Okay. What is a histogram, whether it is unimodal, it's bimodal. If you say it's a unimodal distribution, and let's say the image is like concentrated, the pixels in the image is concentrated in very narrow range of digital number. Let's say on this x-axis, values are 0 to 255, but our image digital numbers are only concentrated between, let's say, 35 to 50, only within the range of 20 DN number, difference of 20. It means in that particular image, there might be possibility like uniform kind of objects are there. Okay, because if the digital numbers are concentrated, they are very close together, they are similar, we can say, it means they represent the same intensity. Okay. Ultimately, the intensity is mapped on digital number. So if digital numbers are very close, it means they represent a similar kind of intensity. And further, if you further go downward in this workflow, if intensity is similar, it means from all the ground cells, okay, the reflected energy seems to be close together based on this one single parameter, that is on the basis of histogram. Okay, so they may the objects reflectance may be similar. Okay, it means the objects are uniform in nature in the image. Okay, so these kind of analysis can be done, and this is the requirement of this experiment. Like first you visualize the image, try to understand the types of features present in the image, then statistically analyze the image in terms of what is the standard deviation of digital numbers, what is the minimum value of pixel, maximum value of pixel, what is the nature of histogram distribution. Do you know when you modify your, when you click the photograph, if I, in very general term, if I discuss, okay, if you click the photograph and if you want to improve the visual quality of image, so if you see in the application using which we modify the image, there is option to change the contrast of the image. Okay, change the contrast of the image, it means you are just stretching the histogram. Like in this case, the value of the histogram, that digital numbers for which you have a significant frequency values, they are, I think, between 5 to 50, let's say 10 to 50. So by applying contrast manipulation, there is a mathematical operator which increase the distribution from 10 to 50. Let's say it could be 10 to 150, or it could be 10 to directly 255. So lower end could be 10 to 0, you make it, and upper end, the maximum value can be stretched to 255. Okay, so the level of stretching, it all depends on the level of stretching. So contrast stretching means by creating the difference between the digital numbers in the image. So that will improve the visual quality of image. Okay. So now Mukesh, you can proceed further.
Okay, thank you, sir. Let me ask you one question. Which DN value is the highest in the number? So you can answer this like you have the DN value 7, 6 in the number, and DN value, suppose you have 18, it is 6, 7, 8, 4 in the number. So which number is the highest? You can see in this row. I think 12,189 is the highest number. So we can see here the 19 is the DN value that is highest in the number. And which pixel is having which DN value is lowest in the number? So you can see many pixels are there which are only 1. Like 75 DN value is only 1 in the number, 76 is 1 in the number, 93 is 1 in the number. So all these pixel values will range from 0 to 255. In this way, you can answer many questions related to this histogram, and it may be asked what is the total area under these pixels. So you can see in the area row, and total area has been calculated here. So certain each pixel has a definite area associated with these pixels, and the total area can be summed up to get the total area under those under that image that has been covered. And one more questions asked by one student, that how to open the images as a color composite. So in the map list, you have one icon in the leftmost top left, at the top left, and in that you can click on that and you can select the images you want to open as a color composite. I am selecting TMB1 for red band, TMB2 for green band, and TMB3 for the blue band. And we can open the image as a color composite. If
Sir,
you
your
want to,
screen is not visible.
my screen is shared, but everyone is facing this problem.
No, I
No,
face you.
no, sir. No, sir.
Okay, okay. So by clicking on the zoom icon, you can zoom the image up to a level that the color of each pixel will be visible to you. And you can minimize the image by using the minimize button. So this is the part of visualization. So in the first experiment, you just need to visualize the images, open the images in the multiple windows to compare the characteristics of those images and see the statistical properties of those images.
Okay,
Suppose,
Mukesh, sorry to interrupt you. If still any one of you facing the problem, if the screen is not coming at you, please let us know.
Yes, sir. Sir, screen is not visible.
There may be bandwidth issue, so that there is a way you can again relog in to Team, so that problem might be resolved. Yeah, this.
the first part of the experiment is to visualize the multiple images together. To do that, you need to open the TMB1 image, minimize this window, place it in the corner, and then you can open the TMB2. and place it a place. Then in the same way you can open the TMB3, and you want to visualize the three images together. In this way you can visualize the three images together to compare the properties of these images. In the next step, you need to make the color composite of those images. To make the color composite, you can click on top left menu, open as a color composite, and you can select the different band of images to make the color composite. So in this way, you can see the after making the color composite, the lake present in the image is clearly identified after making the color composite. Suppose you want to see the properties of these images after making the color composite, you can go to the options and click on histogram. Then histogram of this image will be displayed. In this we can see there are three histograms, and the stretching of these three histograms are different. The next part, you need to see the statistical properties of these images. For statistical properties, visualization or analysis, you can click on the operation tree at the left. In the operation tree, in the statistics menu, under that you have the histogram. For the histogram, you can select the image for which you want the histogram. As the histogram is already opened for that image, so you need to close, and after that you can select the image for which you want the histogram. So for this histogram, I can see the values are ranging from some 25 to 100. And suppose we want the histogram of TMB2, we can select the TMB2, and we can see the histogram of this image is different from the previous image. The histogram is ranging somewhere between 10 to 50, and the maximum values of pixels are lying within the 50. So we can analyze from these histogram that the most of the pixels are within the 50, and this is generally the dark image. Suppose a pixel is having a value 255, then it will be complete white pixel. If a pixel is having 0 DN value, then it will be completely dark. And as the most of the pixels are lying near to the dark pixels, so the image will be generally the dark image. And for if you want, we open the another TM band. Suppose we are opening the TMB5. For that, we can see the histogram of this image is more stretched than the TMB2. Means it is a some bright image. In this way, we can analyze the many more things from the histograms, and students can also perform this experiment at their end also, and they can also ask the questions if they are facing any issue with the experiment.
Hello, sir.
Yes.
In this calculate histogram, when I choose TMB 5, there
Okay.
is an there is an Elvis error 1001 create error.
Okay. Okay. You can select the T from the map list. I think you are selecting directly that image. You need to select
No,
from the
but
TM.
except that all TMBs are opened.
Okay, only TMB5 is not opening. Okay.
Yes, sir.
Okay, let me check. Uh, there might be issue that you have already opened the TMB5 histogram. Maybe that issue. Otherwise, it is opening at my end. If you select the file from the map list.
Yes, sir. Now open.
Okay.
Sir, what we have to write in the file?
For the lab file record, I will instruct you in the next experiment. Okay.
Sir,
Yes, please ask.
okay, so in the map list, so there are three options: red, green, and blue. So
Okay.
how we are deciding to which TMB to choose? Like if I want 2 and 3, so is we give a basic colored image, and there is a variation of 2, 5, 7 give another. How we are deciding which one to choose? Okay, because there is a lot of variation.
Yes, yes. As each band of the image have the different wavelength, okay, different frequency range, wavelength range.
Okay.
Okay, so what type of color composite you want to prepare and what are the requirement? Based on that, this will be decided. Okay,
So
what kind of features?
okay? So how would I know कि TMB2 is which wavelength?
Okay, for more details, you can go to the chapter 6 file. Okay, in that it
Okay.
is given how to make the color composite. What is for what requirement you need to make the what type of color composite.
Because every TMB looks like same basic grayscale image and getting a
First,
colored image.
yes. Visually it is looking like that, but the wavelength range is different for the each TM bands. So for the images, the difference is so small, and we cannot visualize with the eyes. Okay, so for the processing of images, you need to select the bands which you want to that are different for the different applications.
Okay, sir.
Okay.
Sir, what are these values which are coming left side of the latitude and longitude? The right side bottom corner. Sir, can you hear me?
Yes, yes.
Sir, what are these values which is the right side bottom corner? In if we open any of the TMB 1, 2, 3 or anything, when we are
Histogram.
dragging the mouse on when we are dragging the mouse on the picture, then the values are getting changed.
Yes. If the image is geo-referenced, then you will change. You will get the lat long of that pixel. Okay.
And sir,
And
what is that which is beside it?
you will
Large
assign.
value.
Actually, the map is not geo-referenced yet, so these are getting some garbage values. If you will properly geo-reference the image, then it will give the correct values of the lat and long.
Okay.
And this is the part of the next experiment, and I will discuss these things in that experiment.
Okay, sir. Thank you, sir.
Okay.
हेलो सर।
यस अरुण।
सर ये इसमें जो हमने डीएन पे क्लिक किया, जो एरिया डिटेल आ रही है सर पिक्सल की, सर इसमें तो यूनिट तो सर शो नहीं कर रहा है, तो कैसे पता लगेगा एरिया है किस यूनिट में है सर?
इट इज जनरली इन द स्क्वायर मीटर्स।
ओके सर।
Sir,
Yes.
sir, when we double click on an TMB, then a small box is being shown. At
Yes.
the end point, there is a checkbox which is written over there, stretch. Beside that value is given 7 and in next box 75. What does this signifies?
Stretching means suppose one image is the pixel values of one image is ranging from 25 to 70. Okay.
sir.
This is
Yes,
a
sir.
dark image. Okay. Because
Yes.
pixel values are low values.
Okay, sir.
If you want to enhance this image, you need to stretch these pixels ranging from 0 to 255.
Okay.
So the image will be enhanced. For the enhancement purpose, you need to stretch the pixel values. So the
Okay.
lower values pixel will be enhanced to the bigger value, and in this way the image will be enhanced and it will become a brighter image.
Okay.
For that purpose, image stretching is used.
Okay, sir.
Okay. Okay.
Yes. Yes, sir. But the values which is given over here, 7 and 75, what does this signifies? Which is beside stretch checkbox. Sir, can you hear me?
Let me share the screen. Okay.
Okay, sir.
Suppose for TMB1 you have the stretch from 28 to 80. Okay.
Yes.
So in this image, the stretching is applied. Means the pixel values ranging from 25 to 162, and the stretch between 28 to 80.
Yes, sir.
Okay. Suppose you want to stretch the pixel values to make it a brighter image, so you need to change the stretch.
Okay, okay.
Suppose I am making it 250, the maximum value, and minimum value is 0. Click OK. So now you can see the appearance of the image has been changed.
Yes, sir.
Okay. So by default, it
Yes.
is taking the stretch as to enhance the properties of the image. So
Okay, sir.
make it more visually more visually enhanced. Okay.
Okay.
So you can change your values according to your applications. So
Okay, sir.
if
Thank
it is, yes.
हेलो सर।
यस
सर इसमें हमने कल QGIS में जियो रेफरेंसिंग की थी, तो उस फाइल को इसमें इंपोर्ट कर सकते हैं?
हाँ बिल्कुल कर सकते हैं. You can georeference any image in the series.
Sir,
हाँ सुमित बोलिए.
sir, TMB3 has the larger pixel range value, that is from 5 to 130, and TMB4 has from 0 to 103. But sir, the picture, that is photograph of TMB4 is more lighter than TMB3. Why this is so, sir? Even the range is of TMB3 is larger than TMB4.
You are saying the pixels are lying in the low delay
Larger area,
values.
larger. Yes, sir.
Okay, larger pixel value is still the image is not bright.
I mean to say, sir, I'm comparing between TMB3 and 4. The TMB3 has a larger pixel range as compared to TMB4, but TMB4 image is lighter than TMB3.
Okay. Can you share your screen?
Yes, sir. Sir, this is TMB3, this is TMB4. This is much
Still
lighter.
It's still
Yes,
not
sir.
visible. Okay.
Sir, is it not visible?
Now it is visible.
Okay, sir.
Okay, you are asking about the TMB5 and TMB2.
No, sir, TMB3 and TMB4. This is TMB3, this is TMB4. TMB3 has a larger pixel range than TMB4, but TMB4 looks lighter than TMB3.
Okay.
Why this is?
Okay. TMB3 is a dark image from the histogram we
Yes.
can see. Okay. It is also dark image TMB4. So the difference is much less. If the pixel values are lying within the range of 100 to some 255, then it will be clearly visible to us the bright image. It will be it can be classified as a bright image.
So
But
that is
in
bright
general,
is okay, but sir, I mean, sir, when TMB3 has more range in brighter side, that TMB3 should have been the brighter than TMB4.
the change is not so much significant. Many other factors maybe. Change is not
Okay.
significant because all the in the both the images the pixels are lying within the 100,
Yes, sir.
and both are the grayscale images.
Yes,
And
sir.
if you take another image that is having the pixel values going up to the 255, then
Yes.
changes will be significant.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
हेलो सर.
हाँ हेलो.
Yes sir. The class is over.
Okay, sir will inform you.
Okay, now we end this laboratory session, and I hope the steps discussed with you to execute the experiment, today's experiment, you have learned about it, and I expect you to again go through the steps which have been already discussed, and try to understand the experiment in terms of understanding the set of instructions which are there, which are implemented in the software, so that you can able to write the script, your own script, in any coding platform which you are aware. Okay, so thanks for joining this laboratory session. Now you may leave now this meeting session.
Thank you, sir.
Sir.
हाँ सुमित बोलिए.
Someone else is speaking.
सर वो PRS की क्लास मंडे को ही होती है हमेशा.